Today, I want to talk about a real AI research agent. If you remember, in one of my previous videos, I talked about this AI use case where Michael mentioned, what if I can ask ChatGPT to write a Twitter thread every other day about how a famous people get rich and automatically publish it, and you can get 100K followers in just 1 year. And this was a prime use case for GPT. And in the first version, I used Langchain to create a linear AI workflow where I will give a topic and it will go search online, get a list of URLs, then it will try to pick up URL might contain most relevant information for this topic, scraping the website, and then create a Twitter thread out of it. The problem is in real research, it is never a linear process. When we do a research online, normally we will open some URL, scraping the information, then we realize there's new topics to research further. So it is a much more iterative process instead of linear flow. And this is where agents come in, as it has the ability to plan, execute, and reprioritize its task to achieve certain goals. And agent is really just 3 components. It uses large language model as a decision engine, and then it will store all the context in the memory so it can maintain a task list and know what was previous context. And then we'll give it a list of tools to execute the tasks. There are person on Twitter created much more detailed charts about how this could work. In my experience, 80 or even 90% of agents often don't deliver good results because it has 2 bottlenecks. One is the quality of task execution, how well it is actually to complete certain tasks. And the second is the reprioritization, how well it is to make a judgment call that I already have enough information to finish this task, or should I continue going? That's why I think there are huge opportunities in terms of building agents that is specialized in certain tasks. Because unlike general agents, autogpt or babyagi, if you're building agents for a specific use case, then you can ensure the tools that will be used for those specific tasks is executed very well. And also you can provide very good system prompt to help agents make right decisions here. And research is such a fundamental use case that it's not just used for create Twitter threads, but it's building blocks in many different business workflow. For example, we can actually trigger the whole workflow from someone receive an email, use large language model to extract all the information, then feed into a research agent to understand how big this company is, how likely they are going to purchase this product, and then putting all those information into Google Sheets or Airtable as a prioritized list. And when you expand the definition of research more than just Google search, but about other systems like CRM, ERP, customer ticketing system, then this research agent can really stitch together the information from different systems and enhance the decision for human. So today I'm going to show you a step-by-step process of how to build a research agent and embed in your real business workflow our platform like Make.com. And if you're not familiar with what Make.com is, it is basically an integration platform that allowed us to connect to thousands of different business apps like email, Google Sheets, MailChimp, Facebook ads, and a lot more. It's kind of like the Zapier alternative, but much more flexible and also provide a freemium version. And we're going to set up something like this, where it can trigger some requests to our research agent when I receive an email and send the prioritized leads list to Airtable. So let's get started. We'll firstly set up a research agent via Langchain in Visual Studio Code, and then we will deploy the research agent as a web service via platform like render.com. And in the end, we will stitching together everything in Make.com to trigger the research agent from different systems we use. Let's open Visual Studio Code, and as always, let's create a project folder called AI Research Agent, create a Python file called app.py, and then let's break down this research agent into components. So firstly, we will create a tool for the agent to go on internet and search for useful links about the topic. And then we will create another tool for scraping the website content. And in the end, we will connect these 2 tools to a Langchain agent and give a system prompt as a researcher. Before we start, firstly, let's create a .env file. This is where we will import all the API keys you're going to use for OpenAI and other service. And there will be 3 API keys you will need. One is OpenAI API key. We will also use Serper, which is a service that we're going to use to search on internet. And then Browserless, which is another service we're going to use to scraping the web. And if you don't know what they are, those are the URL that you should go and sign up. This is for serper.dev and browserless.io. Once you did that, just come back and replace the API key here. And then let's come back to the app.py. The first thing we're going to do is import a list of libraries that we're going to use. There are quite a few. I will explain one by one and then we will do load.env, which will load the API key from .env file. And then we will grab the API key for browserless and Serper. Next, we will create a search tool for agent to go on internet, grab useful links. And I mentioned before, we're going to use Serper as a service to get results from Google. And this function is pretty simple. We basically just create an API call to the Serper API. So we will create this function called search with query as a input. We have the URL, and then payload is a query. we will put the header pointing to the API key that you have put in .env file. And then we will try to do the request.request. So request is a Python library that we're going to use to send the API request. And we pass on the URL, headers, and payload that we defined above. And this should return a list of search results from Google. On the other hand, Langchain actually provides default Google search tool you can use as well. So you actually don't have to build your own custom tool. If you do decide to use their custom tool, making sure you're using this Google Serper API instead of the Serper API here, because this Serper API doesn't actually return the link. And now let's try this. I will do search, what is Meta's thread product? And we will click on this button on top right corner, and let's try to run this by calling Python app.py. Okay, so you can see it actually returns a list of search results here based on the query I put in. Next is we will create a custom tool for scraping the website data. And we will use browserless as a service to do the website scraping. And the process is very similar. We will pass on two input, which is objective of the research, and then the URL of the link that we're going to scrape. I will explain a little bit why do I need to pass on this objective input later. But firstly, let's using the scraping service from browserless. You will define the header, and then you will pass on URL of the website that we're gonna script, and making sure you convert that data into a JSON format so that browserless can actually take this. And once we did that, the next thing is we will create this if condition. So if response.status code equal to 200, which means it successfully extract the content from the website. And then we're gonna use a Python library called Beautiful Soup to extract the text from the HTML. And that's because at default, browserless will return the whole HTML file like this, which include a lot of information like tags and scripts that we don't really need. By using this Beautiful Soup, it will extract only the text and content. So let's try this script website function that we just created. So it says it's scraping website, and then it returns the whole content. So this is working. But if you use this right away as a scraping tool, one problem you will face with very quickly is the token limit. So every large language model, including GPT-4 or GPT 3.5, all have token limits. So GPT 3.5 can only take 4,000 tokens at one time. Even for the latest version that they released a couple of weeks ago, it can only take up to 16,000 tokens. And to handle the token limit of large language model, there are mainly two ways. One is called MapReduce, which is basically summarize the content. It will break down a 40-page content into small paragraph, and then it will run a large language model call on every single paragraph to summarize it. And in the end, we will merge summary of every single paragraph into one summary. So this is one way to summarize a very large piece of content. And the second method is called vector search. And this is basically creating a vector embedding of a large piece of content. Then we do a vector search to find the most relevant content for certain topics. And these two methods have its pros and cons. But as a rule of thumb, I would say if you are dealing with a huge amount of data, you definitely have to use vector search because that's the most cost-effective one. But for a smaller one, let's say you are dealing with a couple pages of content, then summary or MapReduce is also a decent way to contain the full content. And for this demo, I'm going to use the summary, which is MapReduce methods. So to do that, I will remove this and create a summary function. And in the summary function, I will pass in two inputs. One is objective of the research, and the other is content that we extract from browserless. And this is why we initially were passing on an objective input for the scraping tool, because I want this summary function to actually summarize content with this objective of research in mind. So we will firstly create a large language model with GPT 3.5 Turbo 16K version, and then we will use text splitter. This will break down a 40-page content into small chunks, and each chunk is 10,000 tokens. And then we'll create an array of all those chunks. Then we will create one prompt called map prompt. And this is basically the prompt it will use when it tries to summarize the content. Write a summary of the following text for this research objective. And this is text and this summary. We will create a prompt template from this. And in the end, we will use Langchain's load summarize chain. And this basically package two steps. One is it will do a summarization of every single chunks that we split. And in the end, it will merge them together. So we will pass on the large language model. The chain type will be MapReduce, which is this summary methods we're going to use. And then we'll pass on two prompts. One is map prompt, which is prompt that you will use to summarize each chunk of text. And then the combine prompt, which is the one you will use when you try to combine the summary from each paragraph into one paragraph. And just for this purpose, I'm going to use the same prompt for both map and combining. And in the end, we're going to run the summary chain on documents and give the output. And once we did that, we will move back to the scraping website function and replace this return text to a if condition that if the length of the text is really big, more than 10,000, then we will use this summary function. But if the content is not that big, then we'll just return the full content. So these two functions together is how you can script in the website and feed the content to agent no matter how big text is. And the last thing is for scripting website tool, we're actually going to do something special. And the reason is for search tool is very simple. It only have one input that the agent need to pass on. But for scripting, I actually wanted to pass on two input, objective URL. And when there are multiple inputs, we will need to define it in advance so agent can have consistent performance to pass on both inputs. And to do that, we will create two classes. One is called script website input class. This basically defines a list of inputs that agent should pass on. And we will use the base model. And in here, we will define the two input that we're going to use, objective and URL. And for each one, we're going to give a description of what it is so the agent know what kind of information I need to pass on to this function. And then once we create this input base model, we will create another class called script website tool. This is basically define this function. Name is script website. The function will be used for when you need to get data from the website URL, passing both URL and objective to the function. And then we'll define the argument schema to the script website input that we defined above here. Then you will define what will happen when this tool is called. So it will call this script website function, and you will also need to define what happens if there's error. So this is pretty much it for the script website tool. Just quick recap, you will define the script website function and do a summarize function that will be called if the content is too big, and in the end, we will create a custom tool from this function. Cool. So now we can start stitching things together and create this agent. Firstly, we'll create a tool list that can be passed on to the agents. And one is gonna use search, which we will define the name of the function. And this is function will be called when it will be run. And we'll give description useful when you need to answer questions about current events data. And you should ask target question, which kind of force it to generate a good query for Google. And then second is we will pass on this script website tool that we just defined here. And you will notice that format here is a little bit different. And that's because the search tool is pretty simple and straightforward. We just have one input, but the other one, since it is more complicated, has two inputs, we are passing on this script website tool. And then next is I will define a system message that I will pass on to the agent. So I will give it a role that you are a world-class researcher who do detailed research on any topic and produce fact-based results. And you do not make things up. You will try as hard as possible to gather facts and data to back up research. Then I will give it a list of rules to follow. So you should do enough research to gather as much information as possible about the objective. If there is a URL of relevant links and articles, you will script it to gather more information. And after scripting and research, you should ask yourself, is there any new things I should be searching and scraping based on the data I just collected to increase the research quality? And if the answer is yes, then it continue, but don't do this process for more than 3 iterations because it will be very slow and cost more money. And then you should not make things up. You should only write facts and data that you gather. And in the end, I add 2 rules, which is exactly the same. In the final output, you should include all the reference data and links to back up your research. And the reason I repeat it multiple times is I found this behavior often is not followed. So I just repeat it multiple times, making sure to actually follow. And then I will create this agent arguments where we will pass on the system prompt to the agent. And then I'll create a large language model using GPT 3.5 Turbo 16K as a base model for the agent. And then I'll create a memory variable so the agent can remember the context of previous steps. Conversation summary buffer memory basically means the agent will remember word by word data of recent chat history. The older memory, it will do a summary. That's why here I will define the 1000 token. So it will remember exactly what happened for the past 1000 token, but for the older one, it will do a summary. And in the end, we're going to initialize the agent by giving a tool list that we have, pass on the large language model. Agent type, I'm going to use the OpenAI function calling agent. So it has better performance in terms of extracting information and pass on the inputs for the functions. And verbose equal to true means we can see exactly what agent is thinking at every single step. And we will pass on the arguments that we created here and pass on the memory. Okay, great. Now we have our agent ready. The last thing is we just quickly create a web app using streamlit so that we can see the results better. If you don't know what streamlit is, it's basically a way to quickly create a web app from your Python code. So if you don't have an account, making sure you sign up and then do pip install streamlit. So I will create this main function, and then at bottom, you will define if name equal to main, you will call this main function. So this basically means that this function will be called when the app is running. And we will do streamlit.setPageConfig page title. So this will define the name of your website. And then streamlit.header AI research agent and query equal to streamlit.text input. So this will create a text input from your web app with title research goal. And if query exists, which means user actually put content and text into this input, then we will show a message says doing research for this topic, and we will call this agent. And in the end, once it's finished, we'll do streamlit.info to show the results. All right, let's save this and we are ready to go. Let's run streamlit run app.py. All right, so we have this AI research agent up running. Let's try this. For example, I want to research about why did Meta's new product threads grow so fast? How will this impact Twitter? I click enter, and you can see it starts searching for relevant information and return a list of links. And then it starts scraping the website for relevant articles. All right, so within 30 seconds, it searched across website and give me these results. The Meta's new product threads grow very fast because of instant credibility and integration with Instagram, solving the co-star problem and a few others. So this is pretty decent results, and actually including a list of reference links about where did he get this information from. So you can imagine you can use this information, easily feed another large language model to write a Twitter thread from this. But on the other side, this research agent can also be awesome for lead scoring and background research for salespeople. For example, I can give a research code that I received an email from Jason Zhou at Questive. Who is him and what does his company do? So you can imagine we can ask GPT to extract information from the email and then trigger this research. All right, let's return the result that Jason Zhou is the head of product design of Questive. They basically grab all the information available across multiple different links from LinkedIn to my own personal portfolio site. Already, this can be a research agent for multiple different use cases. But what's much more interesting is actually not using this research agent as a standalone web app, but use it as a web service that can be embedded in your actual business workflow. And it's actually pretty straightforward to do because there are platforms that we can leverage like Maker.com. They already provide thousands of different integrations with those services. And to do that, we're going to deploy this research agent to the cloud as a web service so that it can be called as an API in platform like Make.com. We will use a framework called Fast API, which allow us to turn this Python app into an API endpoint very easily. So go back to our app.py, and then at top, you will insert Fast API Python library, and then we will move down, we'll comment out the streamlit part because we are not going to use it as a web app. And then we will add this part, which we will create a variable called app equal to Fast API. And then we will create a new class called query, use base model, and it has one attribute query, which is string, and then we will create this app.post. And this is basically a way to define what will be triggered when someone creates a post request. You will define this function research agent, and then you will pass on this query into the agent. Then you will return the content. And that's pretty much it. We can try to run this API endpoint locally to test it out. To run it, you will do this unicorn app. The first part app is basically the name of your Python file. So if your Python file is different, you will rename this to be something else. And we will define the port and endpoint and click enter. Okay, so now you can see the API endpoint has been running, and this is URL. What we'll do is create another file called testserver.python to test this out. So inside our import requests, and then I will do a post request to our local API endpoint, pass on this JSON format, query what's Meta's new product threads. So I will create a new terminal by clicking this plus button, and inside I will run Python testserver.py. All right, great. You can see it returns the results, but looks like there are a lot more stuff than we need because it includes the inputs, memory, a bunch of other stuff. And what we actually need is the output. So I will go back and change the API endpoint here. So we will return, let's say, actual content. All right, let's save this, go back here, or run this again. All right, great. So you can see now it returns the actual results that we want. And let's create a requirements.txt file and list out all the necessary libraries that the cloud platform needs to install. And once you did that, making sure you commit to GitHub, and then we will use Render, which is a platform that allows us to host all those web services. And after you create an account, you can click on this new button and click on web service. And in here, you will search and find the repo for your research agent and click connect, give it a name. And we just need to paste the same thing that we did locally. Unicorn app host 0.0.0 port 10,000, and then we'll choose free. Before you move on, also click on this advanced button and add a few environment variables. We will need to define the Python version 3.11.2, which is the latest one. And then you will also add the API key that we defined in the .env file into here. And once you did that, you can scroll down and click create web service button. It will take a while to deploy. But once it is done, you should see a message here, your service is live. Okay, and let's test it out. We can copy this link here and move back to the test server.py and replace the URL to be this hosted web service. And we can try to run this. And as you're running it, you should be able to see some message on the log as well. So you can see in the log, it returns the message properly. And we also get the response in our test server.py file. So now we have this AI research agent live and can be called directly through API endpoint. We can start embedding it in real business workflow with different systems we are using with platform like Make.com. So I will create an account on Make.com. And one use case I want to take you through is once you receive an inquiry email, it can automatically extract core information about company and people, and then feed those information into a research agent for background research. Then we can export all those information into Google Sheet or Airtable. And to do that, let's firstly go to make.com and create an account. If you don't have make.com account yet, you can click on the link I post in the description below, which will give you 1 month pro plan for free for 10,000 workflow operations. And once you create an account, you can log in and you will see a page like this. We will click on this create new scenario, and scenario here basically means workflow. And from here, we'll click on this plus button and we will type in Gmail, but you can also use Outlook as well if you want. And there is one trigger called watch emails, which means this workflow will be triggered when a new email received. And I will click on this add button to sign in with Google. If you are using business account, you will just sign in there and it should work fine. However, if you're using personal Gmail account, the process will be a bit more complicated as Google adds some extra security practice. And I'm going to show you how as well. But if you don't need this, feel free to skip ahead. So if you are using personal account, you will click on this add button, click on sign in Google and sign in with your personal account here and click allow. Then you will probably see a warning message like this, and you will need to click on this guide link to get more information. But basically, what you will need to do is go to the Google Cloud account, sign in with the same Google account, and then you will click on this button on the top left corner, click on this create a new project button. And in here, we can give a name called make integration and then click create. And once you did that, and switch to the project that you just created and go to enable API and service tab. And then click on this enable button, search for Gmail and click on this Gmail API and then enable it. And once you did that, you will click on this auth consent screen, choose external and click create. Then you will give app a name and let's say called make. And you will choose the email that you want to support. And in the authorized domains, you will add 2 domains here. One is integrate.com, which is the older version of make.com. And then you will put in make.com. And for developer contact information, you will just type in your own email address here and click on save and continue. And then you will move to next step, scopes. So you will click on this add or remove scopes button and search for Gmail. And you can select everything about Gmails here. And then you will click on update button here. And you will click on save and continue button. In terms of test user, you can just add the email address that you want to connect Gmail to and click add. Once you did everything, you can review it and click on back to dashboard. Then we will go to credentials tab and click on create credentials, choose auth client ID and choose web applications. Give a name like make and authorize redirect URI with this one. And I post a link in the description below so you can follow. And then we'll click create. Once it succeeds, you should see an option here in the credentials for auth 2.0 client ID. You can click on that. And things on the right for client ID and client secret is the ones that you need. So we will go back to make.com and then click on this show advanced settings button. Paste in your client ID and client secret from the Google Cloud platform. And then click on sign in with Google again. And you will see a page like this. Then you will click on this advanced tab and click on this link at the bottom. And then choose this checkbox, move down and click continue. And that's it. You can see the Google account has been set up properly. And then the next step is use OpenAI as the way to extract the name and company info from this email. So I will add this step with OpenAI. I will use the chat completion methods and use the GPT 3.5 Turbo June 13 model. And I will add a few messages. Firstly, I will give a system prompt. You will help me extract information from email about who sent the email and their company and format it in certain way. Person name at the company name, like Bob Wong at Bold Concept. And then I will add this user message. I just received email from the sender and this is the email address. This is the body of the email. And I will just click on those items on the left side to insert the information from previous step. And please help me extract who sent the email and their company. And I'll click save. And just for test purpose, I just sent an email with this content and let's run this. Okay, so once it's finished, you should have a little bubble here. You can click on that and see the output choice choice. The first one inside there will be message, and it successfully extracts the content surely from Questive. So this is information that we will need to feed the research agent. The next step is we will feed those information to the research agent API endpoint that we just created. So I will click next step and search for HTTP and select make a request. This is basically a way to send API requests, and then map the information we received from previous steps into the columns in the Airtable and click save. All right, so now we get everything up running. All we need to do is just turn on the scheduling. At default, every 15 minutes, it will check all the email received and then trigger this workflow for every single email. And as you can see in my Airtable, it's already start generating a few different records. Like this one I sent from my own email address. It is able to do the research about who this person is, which company it is, as well as a list of reference links. So I can easily know who this person is, how likely he's going to be a good potential client. This is just one example workflow you can trigger for this research agent. You can click on the templates page on make.com, and there are a wide range of different systems and workflow you can build. From your Telegram bot, Google Form, ClickFunnels, Facebook Leads Ads, or even Shopify. And as I mentioned before, if you haven't created a make.com account yet, you can click on the link in the description below, which will give you 1 month per account for free, and you can trigger workflow 10,000 times. I'm super keen to see what kind of use case you guys start creating, and please comment below about some innovative ideas you are experimenting. Thank you, and I see you next time.